I had someone ask me to do a video on surface area of composite figures, so that's what we're going to do here. This video is a little bit out of order as I've only done one surface area video, and that was on the rectangular prism. So this is a little bit advanced from where I am in the sequencing, but I wanted to answer the question. And so what's key in doing these composite figure surface area problems is you need to know how to calculate area of various figures, rectangles, triangles, circles, etc. So if you don't know how to do that, you need to watch the videos on how to calculate area. Then additionally, to do composite figures, you really need to understand the surface area formulas. Now all these are on the formula sheet, so you don't need to memorize them, but you need to understand what the formula is. You can't just blindly follow the formula. You really need to understand it in order to do a composite figure surface area. So just remember, what is surface area? Well, area is, think of it as if you're painting something. You're painting a wall, that's the area. You're carpeting a floor, that's going to give you the area. So it's kind of like filling in something, that's what area is. So when we're talking about surface area, it's basically that. You have this figure that I think about it as you're going to paint. So how much paint do you need to cover that figure? When you're talking about composite figures, you are talking about two or more shapes put together. And when you're talking about surface areas, most often three-dimensional shapes that are put together. And so you just need to find the area of, if you're going to paint that figure, how much paint would you need, is essentially how I think about it. So this is going to be probably a fairly long video because I'm going to do 3 different problems using different shapes just so we can get a good idea of how to do these. So in the first one I'm going to start with is a rectangular prism with a pyramid on top. And so you can think of that as the Washington Monument. This is, it flares out at the bottom, but if it was straight up and down, a rectangular prism on the bottom, and then there's a pyramid on the top. So this is a composite figure. I'm going to try and actually draw something that looks like that. And so here's the pyramid on top. So if you can think of that as being something akin to the Washington Monument. So we'll just put some dimensions on here. We'll say these are, I don't know, centimeters. It doesn't really matter. And so we want to find the surface area. So if we were going to paint the Washington Monument, you need to think logically when you're doing these composite figure problems. So let's think, if we were going to paint this, we would just be painting the outside. So the top of this rectangular prism, we're not painting that, right? So this top, we don't need the surface area of that because we can't touch that. You do paint, so don't think of this as on the ground. When you're doing these composite figures, you do need to do the bottom of things. But the base of this pyramid, we can't see. The top of this rectangular prism, we can't see. So we don't need the surface area for that because, again, I think about it as painting. We're not going to paint that. We do need the bottom, so don't think of this as on the ground. I'm just using this as an example. So we have this thing. It's a rectangular prism with a pyramid on top. What is the surface area of that? So we find the surface area of what we need to paint of the rectangular prism, and then we find the surface area of what we need on the pyramid, and we add those two things together. That is this total surface area. So you pull out your formula sheet, and what's the surface area? It says SA, means surface area, is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Now remember, so think of this logically. What are we trying to do? We're trying to find the area of each of these faces, essentially, and then we're going to add them all together. So the length times the width, that's the base, that's the bottom, right? The length, we're going to call this the length, that's the width, this is the height. I'll mark that later. So the width is 5, length is 6, height is 7. 2 times the length times the width is giving us the area of the bottom. So one of them, length times width, remember area of a rectangle is length times width, so that's the area of the bottom. We're multiplying it by 2 because we have a bottom and we have a top. But in this figure, in this composite figure, we don't need the top. We just need the area of the bottom. Because remember, we're not painting the top part because it's covered by this prism. But we do need the bottom. So we don't need 2 of these. We just need 1 of them. We need the area of the bottom, which is length times width. Then we have 2 times length times height. Length times height is giving us this face, the area of that face. We multiply it by 2 because there's 2 of them. There's this one in the front, there's one in the back that we can't see. Then we have 2 times the width times the height. That's this. Remember the formula for a rectangle is basically length times width, which is here is width times height. That's 7 times 5. That's going to give us the area of this face. Multiply it by 2 because there's 2 of them. So our formula is we're going to take the area of the base, which is 6 times 5, plus 2 times the area of this face, because this face plus the face that's behind it, and 2 times the area of this face, which is 5 times 7. We multiply it by 2 because there's 2 of them. So length times width, 6 times 5, plus 2, length times height, 6 times 7, plus 2, width times height, 5 times 7. So if you plug this in your calculator, you're going to get 184. That is the surface area of this rectangular prism, except for the top, because we don't need the top. Now we need to find the surface area for the pyramid. So what's the surface area for a pyramid? You look at your formula sheet. It's 1/2 PS plus B. So again, you need to understand what this means in order to apply it. P is the perimeter, and they do give that to you. So it's the perimeter of the base of the pyramid. S is the slant height, which is this 4. How far is it on that slant? And B is the area of the base. So here's the area of the base. So remember though, in this composite figure, we don't need the area of the base because we're not painting that. It's covered up by this rectangular prism. So we don't need the area of the base. We just need the area of the outside edges of the prism, which is given by this. So how do we find the perimeter of the base? So if you don't know how to find perimeter, you need to watch that video. So here's the base. It has a 6 and a 5. So how do we find the perimeter of that? You just add up all the sides. Remember, there's 4 sides to this pyramid. There's 6, 5, 6, and 5. So the perimeter of the base is 6. I just add them. Plus 5, plus 6, plus 5. You can look at your formula sheet and you can see that perimeter of a rectangle is 2 times length plus 2 times width. It's the same thing. You just add up the sides to get perimeter. So the perimeter is going to be 22, and the slant height is 4. That's what's given to us. So it's 1/2 times 22 times 4. If you do that, you get 44. So that's the surface area of the sides of this pyramid. That's what we need. We don't need the base. So the rectangular prism, the outer edges is 184. The pyramid is 44. So our total surface area is 228. If this was in centimeters, it's centimeters squared. Remember, area is always in square units. So that would be the answer for this. Again, you figure out what are the figures you have, what are the shapes you have. Look at your sheet, but then you have to understand what the surface areas are telling you and only apply those things that are relevant. If you can't see essentially a surface, then you don't calculate that in the surface area. But remember to do the bottom. You always do the bottom. Alright, we're going to do another one with different shapes. So this one we're going to do with a cylinder and a cone on top. So you can kind of think of that as a pencil. So this is a cylinder and then you have a cone on the top. So if we were going to paint this pencil, how much paint would we need? What's the area of it? And so again, you have this cylinder, but we don't have to paint the top of this cylinder because it's covered by this cone. And in the cone, we don't have to paint the bottom of the cone because it's covered, it's attached to the cylinder. So we're only going to be painting the outer sides of both the cylinder, we're also going to paint the bottom, and the cone, just the sides of the cone, not the base. So again, I'm going to try and draw this. So we have a cylinder. With a cone on top. And we'll say this is 9. So calculate area. These should be a little bit straighter. If you're calculating the area of a circle, which we're going to need, we need the radius. We're going to say the radius is 8. I'm going to say this is 15. So we need the surface area of the cylinder, but we don't need the top part of the cylinder, just everything else, including the bottom, and then the surface area of the cone, but again, not the circular part of the cone because we can't see that, just the outer edge of the cone. And then we're going to add those together. So let's do the cylinder first. You look on your formula sheet, what's the surface area of a cylinder? It's 2 pi r(h) plus 2 pi r squared. Again, you need to understand what this means. So 2 pi r(h), that's giving us around the cylinder, because this is basically 2 pi r is the circumference, and then we're multiplying that by the height. If you think of a cylinder, if you would cut it and roll it out, it's really turns out to be a rectangle. So to find the length of the rectangle, that's 2 pi r, that's the perimeter, times the height. So it's really just like doing a rectangle. But anyway, so that's the outer part of it, is 2 pi r(h), height. So again, this is the radius, this is the height, and we'll get to that. So then what is this? 2 pi r squared. Well, pi r squared is the dimensions, or is the formula for area of a circle. So that's giving you the area of the bottom. It's multiplied by 2 because there's 2 of them. Pi r squared is the area of the bottom. We multiply it by 2 because there are 2 of them. But we don't need 2 of them because remember, we can't see this top one. So we don't need 2 of them, we just need 1 of them. So then we put this in. R is the radius, that was 8. Height, so if we do that, if you plug that all into your calculator, you're going to get 753.6. Pi r squared is 3.14. R is 8, so 8 squared. That's 8 times 8, not 8 times 2, remember. You plug that into your calculator, you're going to get 200.96. So if we add out the outer side plus this base, we just add these together. So for the cylinder, this is the surface area, 954.56. So we took the area around plus the area of the base. That's the area of the cylinder. Now what's the area of the cone? Again, we don't need the base of the cone, we just need the outer part. So what's the formula for the cone? You look on your formula sheet. It is pi rs plus pi r squared. Pi rs, this is s, that means the slant height. So pi rs is 3.14 times the radius, which is 8, times the slant height, which is 9. You plug that into your calculator, you're going to get 226.08. And now what is pi r squared? That is the area of a circle. That is the area of the base. Remember, we don't need the area of the base because we can't see that. We're not, painting that, if you will. So for what we need for the cone, it's just this, 226.08. So for the total surface area is going to be the surface area of the cylinder plus the surface area of the cone. 954.56 plus 226.08. You plug that into your calculator and you get 1180.64, and whatever units it is squared. So that's how you would do that one. Again, you have to use the formulas that are on the formula sheet, but you need to understand them. Like, why do they have 2's in front of them? And if you don't need 2 circles, areas of 2 circles, you only need 1. Here, this was the base of that cone. We don't need the base of the cone. We just need the outer part of it. So you need to understand the surface area formulas. And then you find them separately, and then at the end you add them together. We're going to do one more that has a little bit of a different twist on it. So let's say you have a rectangular prism that has a cylinder sitting on top of it. So if you think of that as, let's say you have a book and you have something sitting on top of it and you're going to paint this. So how are you going to figure this out? Well, you're going to figure out the surface area of this rectangular prism, remember including the bottom because we always paint the bottom, and then you're going to figure out the surface area of the cylinder on the top. And then I'll show you. So on the top of the rectangular prism, on the top of the book, we're not painting this part that's underneath. So anything underneath there, we don't need the surface area for that because we're not painting that. Same with the cylinder. We don't need the bottom of the cylinder because it's covered by the rectangular prism. So let's try and figure out the surface area of something like that. So I'm going to try and draw this. Let's try and draw it like this. And then we have a cylinder on the top. Okay, so that's not drawn real well, but you get what I mean. For 10, and here I'm going to give you the diameter is 6. So not the radius, but the diameter. And here the height is 8 of the cylinder. So again, we're going to find the surface area of this, and then the surface area of this, and I'll show you how to take this out. Okay, so let's find the surface area of the cylinder first. So you go to our formula sheet, it's 2 pi r h plus 2 pi r squared. 2 pi r squared. Okay, 2 pi RH, that's giving you around the thing. So 2 times 3.14. What's R? I gave you the diameter, which is 6, so the radius is 3. So be careful, because in problems like this, they might give you the diameter, but what you want is the radius, so make sure you're using the radius. So the diameter, or the radius, is half the diameter, which is 3. The height is 8. So if you put all that together, plug that in your calculator, you get 150.72. Now, 2 pi r squared. What's pi r squared is the area of a circle, so we're multiplying by 2 because we have the bottom and the top. But remember, we don't want the bottom, we just want the top. So we don't need 2 of them, we just need 1 pi r squared. That's going to give us the top. So pi r squared is 3.14. Remember, the radius is 3, not 6. 3 squared is 3 times 3. And if you multiply that out, you're going to get 28.26. So the surface area of the cylinder, we add the outer part together along with the top, 150.72 plus 28.26, and we get 178.98. So that's for the cylinder. Now we're going to do the rectangular prism. Okay, so you need to think again on this. So first we're going to go to our formula sheet. Rectangular prism, 2 length times width plus 2 length times height plus 2 width times height. So we're going to call, oh, I guess I didn't mark the height over here. The height is 7. Okay, so 2 length times width. So here's how we're going to approach this. We're going to find the area of the whole thing and then subtract out this area on the top. So we're going to do 2 times length times width. That's going to give us the area of the bottom and the area of the top, right? Length times width is giving us the area of this bottom face. We're multiplying by 2 because we have 2 of them. Now, later we're going to subtract out, remember the top of that cylinder, we don't need that because we're not going to paint that. So we're going to subtract that out. That's how you do this, is you find the total thing and you subtract out what's not going to be painted. So 2 times length times width plus 2 length times height plus 2 width times height. You plug that in your calculator and you're going to get 276. Now, again, we could have done this by only finding one and then finding the other where we subtract this out. But I decided just to do, we found the whole thing of this whole rectangular prism or box on the bottom. We now have the total surface area of that. If we were going to paint the whole box, every part of it, it would be 276. But remember, on the top, we have this cylinder sitting on the top of it, so we don't need, so here's a top view. There's a cylinder sitting on the top of it. We don't need this part of the top painted, so we're going to subtract that out of our total area. So remember, this has it's a diameter of 6, so radius of 3. So, and it has the dimensions of 4 and 10. Right, so this is, we're looking straight down on top of this figure, and we're going to take out this area right here. So how do we find the area of that? It's just the area of a circle with a radius 3, right? This has radius 3. So what's the area of a circle? Pi r squared. So 3.14 times radius, which is 3. 3 times 3, and that's going to give you 28.26. That is the area of this part of that cylinder that's sitting on top of that box. So since we don't need to paint that, if you will, it doesn't have to be part of our surface area, we're going to subtract that from what the surface area was. So we're going to take our total surface area and subtract that out. And that is going to give us 426. Oops. No, sorry. That is going to give us 247.74. So this is the area of the cylinder, or of the rectangular prism, that we actually need. It's because it subtracts out that top part. So now we have the area of the cylinder that we need, the area of the rectangular prism that we need. So we're just going to add those two together. 178.98 plus 247.74, and the answer is 426.72. And then whatever units we're using, if they're meters, it's meters squared, feet, feet squared, etc. So that's how you do composite figures. You really need to understand the area formulas, the surface area formulas. You don't need to memorize them, but you need to understand them. And then you need to think logically, what do you need from each of these figures that are part of this composite? And only find the surface area for those areas that you need, add them together to get the total surface area.